Hi everyone, I'm Jorge Lopez-Alvis. I'm a PhD student in University of Liège and Ghent University, and I'm part of the Enigma ITN project funded by the European Commission. I will present a little bit about my research project, which is updating uncertainty in hierarchical subsurface models using geophysical data, and particularly a synthetic case for GPR data. The main purpose, as introduction, I will only mention that when we work with subsurface systems, we always have to deal with uncertainty due to our prior knowledge of the subsurface. So how can we deal with this uncertainty? We work with a joint probability distribution, and then we work within a Bayesian framework. That is, we start with a prior distribution, and then we condition this distribution to data and get the posterior distribution. So one way to do this is to work with a joint probability distribution of both the parameters and the data. To add more complexity to the subsurface structure, we can work with hierarchical Bayesian models. So here we will just add uncertainty at different levels, and then we will just build with this. We will build the joint probability distribution. Now, to approximate this joint probability distribution, we will generate Monte Carlo samples. So how do we get these Monte Carlo samples? We just follow the arrows in this graphical representation of the hierarchical structure, and once we have the samples, we just try to estimate the posterior probability distribution. The problem with these samples is that they are very high dimensional. So one way to deal with this is to use feature extraction and also dimension reduction techniques. So we deal just with the dimension of the data, and we apply, for example, a histogram as a feature extraction, and then to further reduce dimensions, we use multidimensional scaling. To be able to approximate the posterior probability distribution, we use a technique called kernel smoothing. This kernel smoothing just works up to 10 dimensions, so multidimensional scaling will allow us to work with this just only 10 dimensions, because the original dimensionality of the data is, for cross-hole GPR, is the number of sources times the number of receivers. So we will end up with a very high dimensional data vector, and which is just the number of sources times the number of receivers. It's around 722 in this case, because I have 90 receivers and 90 sources, and then I'm working with reciprocal data. So once we reduce the dimensions of the data, we just apply kernel smoothing, and since here I'm dealing with just one uncertain parameter, which is the geological scenario, I will get 3 different posterior probability distributions. And then finally, just to see that the method is working, comparing the different feature extraction techniques, we perform cross-validation. And once we have this cross-validation, we can also conclude how informative is GPR cross-hole data for identifying an uncertain parameter, in this case, the geological scenario.